Today I'm going to be talking about the difference between a convergent versus a divergent series in the abstract. In order to really do that, I'm going to have to talk about sequences. Yes, there is a difference between a sequence and a series. Here's a sequence. In the abstract, you just have a list of values. So A1, A2, A3, and this could go up to some value n, or it could just go on forever. I'm going to let it go up to some value n. A sub n, and close. Well, let's say you had this set of numbers, or this sequence of numbers, 1, 2, 3, 4. And let's say I stopped it right there. That's a sequence, and you could start to ask the question, well, first of all, couldn't this just go off forever? Yeah, it could. Let's instead do 1, 2, 3, 4, dot, dot, dot. This right here is the same as taking what I wrote up here and doing the limit as n goes to infinity of a sub n. And so this notation, you just do 1, 2, 3, 4, like the terms, and this just goes off forever. You can also see this written this way. They'll do the curly braces, a sub n, and they'll actually put n equals whatever. It could be 0 or 1, depending on your textbook or the problem. I'll just do 1 to infinity. Okay, so now that I've set all this up, this is a sequence, just a list of numbers, we can talk about the sum of the certain number of terms of a sequence. So let's say I look at this one right here, which is just 1, 2, 3, 4. You could add them up. You could do 1, which is just 1. You could do 1 plus 2, which would give you 3. You could do 1 plus 2 plus 3, which would give you 6. You could do 1 plus 2 plus 3 plus 4, which would give you 10, and so on. And so what we would call these are partial sums. I'm taking individual, like cutting it at certain points. Now, I can't jump around. I can't be like, ooh, 1 and 4, and let's grab 17. For sequences, for doing partial sums, you have to go in order. So this would be the first partial sum, and we would call it S sub 1. This would be the second partial sum, and we would call it S sub 2. This would be the third partial sum, we would call it S sub 3. And this would be the fourth one. And when you get down here and you start going 1 plus 2 plus 3 plus dot, 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 plus n, this is an infinite, it does stop. That equals something, and whatever value that is, I would just call it S sub n. So this would be a partial sum, S sub n, 1 plus 2 plus 3, etc., up to n. So now I can finally talk about what it means to converge versus diverge. Well, right here, these are now partial sums. As soon as I make this infinite, and so I say the limit as n goes to infinity of the partial sums, we have a series. You're taking the terms of a sequence and you're adding up infinitely many of them. By definition, this would be a series. And so what we would have here, if I want to write this in sigma notation, is sigma, the sum, n goes from 1 to infinity. And what are we doing? We're doing 1 plus 2 plus 3 plus 4. And what's n doing? N is going 1, 2, 3, 4. So this would be the sum as n goes from 1 to infinity of n. And you can ask, does this converge or does this diverge? Now, the actual process of figuring out if something converges or diverges is itself a complicated thing to do. There are so many different kinds of tests for whether a series converges or diverges. But whatever those tests are, and however you're going to do it, what I'm interested in is the idea, and that you understand what the idea is, what we're doing when you get into the test for testing this sort of thing. And so what we're doing is we're just taking a sum, adding up the terms of a sequence, and letting it explode, basically go off to infinity. Sometimes you'll have an actual value, an answer you get, and sometimes you don't. I'm not going to go through the tests on how you determine that, but I am going to tell you that this right here diverges. I haven't done anything to prove that to you, But I'm just telling you, this does not give you a finite sum. And maybe intuitively it makes sense to you that this wouldn't, because look at it. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That doesn't sound like it's going towards anything, right? It's just getting bigger and bigger and bigger and bigger. This is diverging to infinity, in fact, positive infinity. Now, you're not usually asked to specify what it diverges to, but in this case, that's what's going on. This just explodes. Before closing off here, I will give you an example of a sequence which does converge. Again, I'm not going through how you go about to proving this converges, but I'm just giving you an example, and hopefully intuitively it makes sense to you that this one would converge. Say you had the sequence which went 1/2, 1/4, 1/8, and just kept doing that. Well, this is powers of 2, and so the partial sums, S sub 1 is just a half, it's the first term. S sub 2 would be a half plus a fourth, which is 3/4, and so on. 1/2 plus 1/4. And so on and so forth. And so as you do these partial sums, you get values, 1/2, 3/4, and so on. Now, if you set up the actual series here, so the limit, as n goes to infinity, of these partial sums, and now S sub n is referring to the partial sums of this sequence, that's the sum. N goes from 1 to infinity, and this is 1 over, look at it, powers of 2. 2, 2 squared, 2 cubed, and so on. So this would be 2 to the n. Now I will just tell you that this right here is a convergent series. Converges, and the value, like what is the sum as n goes to infinity, the infinite sum, is actually 1. I haven't done anything to prove that to you. I don't want you to think like, wait, I don't understand. How are you getting that? I haven't shown you how. I want you to focus on this is convergent and to compare what's going on, what's different between the sequences. In this, the numbers get bigger and bigger and bigger. 1, 2, 3, 4. Here, notice the numbers get smaller and smaller, a half, a fourth, an eighth, etc. So it doesn't always mean if they get smaller, you're always going to have a sum. Not always, but this one does converge. It converges to 1. And when you get into more series and you start doing convergence and divergence tests, usually you won't really be asked what the sum is. What you care about is just this part. Does it converge? Does it diverge? So hopefully this has given you some idea of just what it means to converge or diverge. If you add up an infinite number of these terms, this explodes, diverges. If you add up an infinite number of these terms, this converges. It settles down into one nice sum. And that is the difference and the idea of convergence and divergence.